Shake, shake. Good, man. Now put it in the bowl. But now, here, 150 degrees, it loses its magnetism.
That's pretty interesting.
And now you put it on here, and now she has it back. 1550, before it actually starts melting completely, you can actually take it, the domains are broken, and you put it on the magnet, and when it's no longer magnetized, you know it's at the right temperature. So you either use it with your eye over time and you know the color, or you want to double check, you put it on there and it won't magnetize, stick it in the quench, and then it's back to being magnetized.
Ancient blacksmiths know that?
Yeah. And this is high carbon steel out of a spring. Guys, watch your faces here. High carbon spring, which we super quench, which you're not supposed to do.
So, yeah.
And what happens, you can see the end of that.
Carbon and steel makes it
Let me focus.
like very, very hard, but it cracks and it's brittle.
Well, yeah, yep.
What happens when you melt it, the carbon molecules, because carbon is, like we say in chemistry, carbon's a whore. It combines with all the other carbons and you get a carbon chain. So when you get it to that temperature, they have a tendency to migrate together and get away from the other atoms. And if you super quench them, now they're stuck in like chunks. Carbon, carbon, carbon. And if you hit it, it'll fracture along those domains.
So you don't want too much carbon. Well, maybe you do want a lot of carbon in your
You
steel.
do, but what you want to do is take it and let it cool gently. You know,
Like
ash. Wood ash works perfect.
Steel.
You could even actually let this just air cool and it would be perfectly strong.
Sometimes
So when you do a
want
knife or a blade,
I see.
you want to have the tip high carbon, right? And then you want the end to actually have some flexibility. So you want it tempered differently.